Welcome back. Today I have a treat for you. Let's see what we are working on today. Oh, what could we be doing with this? Remington Model 700 223. Wow. The instructions are to cut this barrel down and thread the end for, I'm assuming, a solvent trap. This is going to be a good time. Let's get at it. First we got to measure what we have here. And how we do that, you take something, anything that'll fit down the barrel, is at least the full length of the barrel. Shove that down there, and we measure up to where the bolt stops, which there's a big shoulder in here. I know the bolt isn't going to go past that. We'll shove the rod up to my finger, that's where the bolt should stop, and we'll make a mark on the rod at the end of the barrel. If I can find something, here we go. So I got the rod up against the tip of my finger, that's where the bolt stops. Make a mark on the rod. Pull it out. And then we will measure up to the mark. We are at 24 inches right now. And we want to take that down to 17.5. That is a full inch over legal size. Legal in our state, and I think everywhere, is 16.5 inches. Cutting down a barrel and threading it may not be legal where you are. It is here. So if it isn't legal where you are, look away. Alright, I taped up the barrel so nobody knows what it is, and to keep it from getting marred and scratched up when we're working with it. We're at 24 inches overall total right now for the barrel, and we want to be at 17.5. So we got to take out 6.5 inches, right? Yes, 6.5 inches. So we just simply measure from the end of the barrel 6.5 inches, and we make our very precision mark right there. See? 6.5 ish. And we let the fun begin. I'm going to leave a little more than the 1/16 of an inch proud, just so we have some room there for cleaning it up in the lathe. There we go. This is still that bad blade from the exhaust job on the SS. I haven't gotten around to changing it yet. A lot of things going on. So yeah, there's our 6.5 inches. Maybe we can do something with that someday. Ooh, that would be fun. A little mini cannon, desktop cannon. The possibilities are endless! Endless! We are over at my Logan lathe. First thing I gotta do is change out this 3-jaw for my 4-jaw so I can dial that barrel in perfectly centered. We don't want it wobbling and wiggling all over because our cut won't be straight. These weigh about 60 pounds ish. Carefully guide it on there and thread it on. Whew. Unfortunately, because of the big receiver on the end of this barrel, the barrel doesn't come off of the receiver. I couldn't fit it down the spindle bore. The spindle bore on this Logan is 1.25 inches, 1.5 inches or something, I forget. There's just, can you see here? There's just too much here protruding to fit it down the spindle bore. So I had to dial in on the receiver in the 4-jaw and dial in this end of the barrel, and then we will have to go down to the other end of the barrel and dial in on a steady rest. It's not perfect, but it will have to do. So I got this end dialed in. The dial moves around maybe a 0.5 thousandths. Where's my wrench? Where's the wrench? Where's the wrench? Where's the wrench? They're just on this high side. Quarter thousandths. Not much movement at all. Go back here, you can see these are copper shims I use. That's to not mar up, even though we have tape on here, we don't want to mar up the barrel underneath the action. You can see a couple of marks from the chuck jaws. I didn't tighten down very hard or snug with the chuck jaws from the beginning, just enough to get it to hold it in here to get it set up, and then right after, one by one, I went around and put in the copper shims and then started dialing it in and cranking down on the jaws. Well, now I'll go to the other end, set up the steady rest, dial that in, and we can start turning, hopefully. Okay, I got the steady rest set up. I wanted to show you a couple of things. Has to do with any kind of tubing. In this case, a barrel. Pretty much any round part that has a hole in the center. You can never rely on the outside diameter, the outside surface, to be concentric with the inside. I know I did up here on this end for setting up the 4-jaw. I couldn't help it. I can't get inside down through the spindle to indicate off the bore on the inside, so I had to rely on the outside to dial in the 4-jaw. But I wanted to show you what I am talking about. The lathe, the machines are going to be loud. I hope you can hear me over them. We'll see. Start up the lathe. And if I can get you down in here, you can see that the outside is running through. It has to be. looks good. I'm going to run a deburr tool, just a handheld, inside this bore to clean out the burrs, and we'll bring that steady rest, or we will bring the live center up, center it up, and okay. Got our live center pulled up in here. I deburred that bore, a clean bore, just so this live center sits perfectly centered in that bore. The thread we are after is a 24 thread per inch, 5/8 overall. First thing I'm going to do is mark out 5/8 of an inch so we know how far in we're going to be turning to. And then I'm going to start out with taking down this diameter, because this is like 7/8 of an inch outside diameter. So we got to take this down to 5/8 diameter and 5/8 in. Check where we're at. You're at 700 exactly. We got to do. We gotta do 15 thousandths. Should be it right there. Yeah, we got 1,000th. That'll be alright. We'll leave this high-speed steel blank. This does a little bit better. We only got a few thousandths to go, and then we'll be at our 40,000th depth. See if this sounds better. That was junk as well. Let us set up, start threading. Okay, we're gonna try some threading here. I just made sure everything is gonna clear. We got plenty to come in here, all the way across, and we're gonna stop in this slot that we cut. That's our relief for the thread stop. I got my threading dial engaged. We are ready to start threading. Oh yeah, compound set at 29.5, and I'm gonna touch off, zero my dials here, and we'll do a scratch pass and check it just to make sure we are on 24 threads per inch. And scratch pass. Do our thread check here. Find a cleaner spot. If I can get it in here. It'll look like we're right on. Nope, should be good. And we'll repeat until we're at, well, I'll stop at 38 thousandths in, and we'll do a check with the thread and see if it fits, see how it is fitting. 0 and a few thousand. And repeat. That looks a little better. Let's get this stuff out of the way. See how close we are. Tight. That's good. So we're not there yet. Just starting to go on. We are just about there. That thread's on, but it's just a little snug yet. I think we'll go another. Boy, that's close. Go another just thousandths. We want this to be close. We want it to be a sloppy thread. Thousandth more. I think we're there. There just might be a little bit of burrs and stuff. I didn't run a brush over it that last time. Let's turn. We're gonna do this taper first because this one is gonna take a little more work. We're gonna do a little taper chamfer on there, and then I do have to do a crown on the end yet because this is a barrel. So I'll have to bring the steady rest back over, set it up right here, right on the very edge, pull the live center away, and we will have to do the crown. Hopefully it runs true enough where we don't have issues with the bore, but we'll see how it goes. I am just cranking the compound in and out for this. Do a turn in the cross like 10 thousandths or so, and then compound again. 10 thousandths. That looks good. Bring it over, I'll do the same but smaller on the very end, just to clean up these threads, give it a nice start, and take the burr off the end. So same thing, we'll set up right there. Alright, there's our thread. Looks like it'll work. Now I'm going to set up that steady rest again like I said here. Pull away the center and we will do the crown on the very end. You can see on the original barrel end of this one, it is just a concave across the entire tip. Like I said, usually on a smaller barrel there is a radius, an arc that goes all the way around between the bore and the outside of the barrel. These thicker barrels like this, I've seen this quite often where the entire tip, the end, is concave. The reason for that I honestly do not know, but that's what they had. Because this is smaller now, we are going to go for more of a crown, the arc from the bore to the outside this taper. For doing these crowns, I have a few of these high-speed steel blanks again, which I cut or grind. Oh, can you even see that? A radius into. I have a few different sizes. Usually picking a radius that fits what I'm looking for here. Let me get my tool centered up here. Yeah, that looks good. I like that. I'll get you in for a better shot here. As far as the barrel goes, we are done with the end of the barrel. I just got to chuck up this other piece, like I said, do the matching 45 here, so it'll thread up. The two 45s will mate with each other. It'll be self-centering and repeatable. Sorry, I wasn't recording. Last pass here. This is titanium. This attachment. I got the compound set at 45 degrees. I am turning the compound and just using the cross slide for adjusting. So touch off here. Just gonna do a cut 5/1000. These cameras are not good at focusing. You see, you get a very nice finish out of titanium. Let's see how it matches up to the barrel. Here's our fitting. See, taper. This is titanium. Here's our threaded barrel. You see that slight crown put on the tip. There's thread. So a nice snug fit. You see, hopefully our taper comes up. Nice stop, snugs up good. That finished off flush. Looks good. Now this guy will be able to put his can on here and catch his solvent. Thank you for watching. Watch for more videos. I see people all the time talk about how titanium is flammable. And I just wanted to show what they're talking about. Because flammable, it can mean many things. It can mean that yes, it can burn, or almost explosive, highly flammable. I just wanted to give you guys an idea about titanium shavings itself, what flammable means in titanium. It's not what you'd really expect. See, it's almost like steel wool when you touch a battery to it. It isn't like it just lights off, burns your house down. It just tracks, burns up like steel wool. Very hot, you can see how bright it is. And that's about it. So yeah, it burns, but it's not as exciting as one would think it is.